Hello everyone. So we have got this interesting question from the chapter of electric fields. Okay, so let's make this diagram first. This is point A, this is B, and the topmost point is C. Now, semicircular electric fields exist. All right, and the direction is something like this. So this is the direction of the electric field. Okay, and the arrow has been given in the diagram itself. So yeah, and we have been asked to find out the ratio of A1 and A2, where A1 is acceleration at this point and A2 is the acceleration at this point. So let's think about what the value of acceleration can be when now since it is there is an electric field, it means that this particular particle which is there at A right now, initially, that will be accelerated, right? Its acceleration will be along the electric field at that particular point. At point C, the electric field, the direction of the electric field is horizontal. So the direction of acceleration will be like this because of that electric field. Now, since this motion is accelerated, it is quite obvious that the particle must have gained some velocity as well, right? So, along with this horizontal acceleration, there will also be a downward acceleration, not downward, but uh, you know, in the perpendicular plane, that will be because of centripetal acceleration. Okay, that is v square by r basically. Okay, and that will be because of the velocity which it has gained. So the net acceleration will be basically sorry, not a1, let's name this a. So the net acceleration will be a square plus v square by r square. Okay, all right, so let's begin. So let's say the velocity at point C is Vc. Okay, so the value of Vc, we can use this formula V square equal to U square plus 2 AS. Okay, now you might have this question that, you know, this is a circular path, right? Why am I applying the formula for straight lines? This is a formula which is reserved solely for straight lines, right? This is because the acceleration here is also changing its direction. So the acceleration and the motion of the direction have basically an angle of 0 degree between them. So this is also technically uh, a straight line movement only. Okay, so yeah, let's get started. So vc square will be, acceleration is force by mass, right? Force by mass, and yeah, force, this is qe is force by mass into the distance. The distance will be pi r by 2, right? Because this entire length is pi r, half the circumference of the circle, right? That is pi r, and a to c, the direction will be pi r by 2. So this will be pi r by 2. So let's cancel out these terms, and vc square is equal to qe pi r by m. Okay, now let's find vb square, velocity of particle at b. Vb square will be, again, the initial velocity was 0, right? So it will be 0 plus 2. Acceleration is again constant, kv by m into pi r, and therefore vb square is equal to 2 qe pi r by m, right? So now we will get the centripetal acceleration if we divide this by the radius of the path, which is constant, that is equal to r. So this divided by r and this divided by r will give us this particular term, QE pi by m and 2 QE pi by m. All right. Now, uh, now finding the acceleration because of the electric field is not very difficult. It's basically QB by m only, right? So let's find the ratio A1 by A2. A1 by A2 will be root. Now they're perpendicular, right? So we to find the net acceleration, we'll just find this root of the sum of squares of both the accelerations, which will be QE by m whole square plus QE pi by m whole square, and this will be divided by QE by m whole square. This is constant, right? Plus 2 QE pi by m whole square under root. So if we cancel QE by m from the numerator and the denominator, it will look something like this. QE and m are cancelled. QE and m are cancelled. So the answer to this will be root 1 plus pi square plus 1 plus 4 pi square. And we have been as a value of k. Okay, so in the question it was given, we have to find the value of k for this particular expression, pi square by 1 plus k pi square. And you have your answer, right? The value of k is 4. So the key insights from this particular sum is that even for a circular path, you can use the formulas for straight line provided the acceleration is also in the same direction as that of the path. Okay, and yeah, that's it. Thank you.